Hello everyone, welcome to another Tech Tuesday. We're actually starting this one, and you can even see on my screen, right on time today. No technical issues. So this is Ryan Goodman. I'm really excited to be with you guys for yet another Tech Tuesday where I can share with you something, nothing actually brand new, but something that we've been generating a little bit of buzz about on our blog. We've recently created a new template that we released to our customers and users of CMaps plugin that basically helps you along the path of creating Choropleths, or also known as heat maps. And so the idea is simple. You want to bring in regional information, whether it be world by country, your custom territories, your country by state, whatever it may be, and be able to align data and use that data to drive the intensity of color. And so in this case, we have something like world population that uses some very simple math to indicate who has the highest population in the world. Obviously, China, then India, then the U.S. But the other interesting thing about this is that in something like a Choropleth, you can change some of your assumptions. So we can do something like eliminate outliers dynamically to kind of get a better picture or sense globally who has the largest population. So if you have your data that's skewed by outliers, in this case China or India's populations which dwarf that of the rest of the world, we can use dashboards to eliminate outliers and provide a better picture for our end users. And so you can actually see as we remove the top outliers, and we could use a percentage-based outlier elimination too to paint a better picture. And then we can also use things like median or average to drive different types of choropleths. So in this case, I'm using the global average of population, and then anything above that average has kind of an orange tinge to it, and anything below that average has a bluish color to it. So you can see it's not necessarily as simple as dragging a map, putting some data in it, and then coloring it in. You do want a little bit more control so that you're telling the right kind of story to your end users. Do you care about population as it relates to the average, or do you care about just understanding where the highest concentration of populations or sales or expenses or profit or whatever that measure may be? So the big question that we always tackle on Tech Tuesday is, okay, this is great, how do we actually put something like this together? So the good news is that we do have a template that we've put together for you guys. And so what I was going to do today is kind of spend a little bit of time walking you through the template. As you can see here, there's really not a whole lot to it, right? We have our source data, which can come from really anywhere. In this case, obviously I have some dummy data in Excel, my world by country, but you could populate this from web intelligence, you can bring it in through BI queries, however you may want it. So we have world by country, we have a few statistics, so population, sales, expenses, profit, and so on. And so in my dashboard, I want the ability not only to change the measure, so we're using a simple column insertion to change the measure. So if I pick population, it sticks population there, sales, and so on. So that's kind of the basic data layout. And then what we've done is we've set up our alert logic, so our Choropleth logic, and then we've also allowed us to dynamically change the colors. So you have that effect of a heat map versus showing an average-based Choropleth. So I'll show you how that's done and the tool that we created so you can create these nice-looking colors. Other than that, as I mentioned, there's really not much to it. So what I was going to do is walk you through the CMaps plugin portion so you can see how quickly and easily you could create this type of map. So I'm going to open up the property sheet here. I'll close out my components, give us a little bit more space to work with. So I have one single layer of information, and this layer of information is my world by country. So in this case, we want our country's boundaries, so the shapefile. So we define shape data. I indicate that yes, I do want to use my shapefile URL. I have the metadata for that shapefile, so this is a list of all the countries I have available to me. This is your opportunity also to change your country names as it will match to your business data. So maybe United States is United States of America or USA or something else in your business data. This grants you the opportunity to make sure that your business data is going to match up to the metadata. And then we have the business data that actually comes in from your query. So this is where that relationship is established between the raw boundary data and the BI query that you're bringing in. So with that relationship established, now we just have to define the coloring and the visuals. That's frankly the easy part. So our labels are going to be our countries. Our values is going to be what I select from this top selector. So if I pick population or sales, it's going to insert it here, and that's going to drive the values. Now, values are going to be very important to us here because this is actually how we change the color of our map. And so where we do that is on the Alerts tab. So alerts grant us quite a bit of flexibility to dynamically change the color of each individual location on our map using some simple logic. And in this case, what we're doing is we're using our value-based alerts, and we're assigning the color of our choropleth using predetermined values to set the scale for how things are colored. And so using value alerts, we then bind our thresholds. And these thresholds are dynamically calculated using a min, a maximum, and a midpoint. And so once we have the min, the max, and the midpoint, anything from there is very easy to calculate to make sure you have an even distribution of steps between the min, max, and midpoint. And so the idea is that we can calculate the min, we can calculate the max, and this selector down here that I was using for adjusted median and average, this is simply a dynamic calculation. And so let me show you where we get each one of these calculations, because this is really the most important part, which drives the logic for the choropleth. So if I scroll over all the way to the right here, you can see this is where we get our logic for midpoint, adjusted, median, and average. So in all cases, I'm calculating the minimum. We have midpoint, which I'll come back to, and then we have our max. So the midpoint, I'm getting three different ways. So the first is a simple calculation that literally gives me the midpoint between my min and my max. We have the median, which is an Excel calculation which finds the median value of the actual raw data. So I'm calculating a median based on the measure that I've selected. And then we're simply calculating an average based on my selected measure. So each one of these three things kind of illustrate the different ways of getting the data. And so what I've done is as I select one of these values here, I'm simply sticking the correct min, midpoint, and max, correct that, into the corresponding blue cells here. So if I click midpoint, adjusted, median, or average, I'm just sticking the right values into the right place. And so what happens is the map uses the results, or these values, to dynamically generate our alert levels. So we can bind the limits, which can be dynamically driven based on your data and some very simple logic to drive these alert levels. And so for each one of these levels, we need to associate a color. And so we have these hexadecimal color codes that once again, for each one of these, we have these different hexadecimal color codes. Now here, so the big question is, all right, now how the heck do I get these color codes? Where do I get these from? And so what we've done is built a very simple tool inside of the Choropleths tutorial. So all these steps that I walked you through, we have here in a step-by-step explanation. We also have some sample hex codes, but if you want to create your own, we've actually embedded a nice little utility. This is what we use internally, where I can enter in a code here, generate how many levels I want. So maybe I want 7 levels, and it will actually generate the code for you. Or maybe I want this here, so it'll give me different shades of red. So I can actually take this, copy it, and paste it right into my dashboard. This is a brand new tool, so we will have an actual color picker here. We want to make sure we got this out the door, but we'll eventually have a little color picker, so you have a nice WYSIWYG color chooser. You could also do 3 colors if you wanted, so that heat map where I use population to go blue or red, this is actually how we achieve that. So it'll assign a midpoint for our 3rd color. So that's how we get our hexadecimal color codes. And once again, we simply bind those. And so once we have that, we're done. That's really all that we need to do to assemble the Choropleths. You bring in your values, so your raw data. You turn on alerts, you define your limits, which you have complete control over, and then what color do you want for each limit. And that's really it. And from there, you can also decide if you can actually flip the Choropleth. So maybe something like sales, a high value is going to have a very intense color, but something like expenses, you want low values are good. So we have the ability to also dynamically change that information also, which is then bindable. So for those of you dashboard developers who have always struggled with alerts and not being able to dynamically change your alert definition, you certainly have that ability with CMaps to do that. And for those of you who, for extra credit, I guess, who are curious how I got that slider to work, let me go and show you guys basically how that works. So if I go here to my midpoint for adjusted, what I'm doing here is I have my maximum value is using a function called large. And so what this will do is it will get you the largest value, the first largest value. So if I move this to a 2, it'll be the 2nd largest value, 3rd largest, 4th largest, 5th largest. So what we're doing in this slider is essentially systematically eliminating your outliers. Now, we can absolutely dynamically drive this using some very basic math. So I wanted to do it so that I could use a slider to show you, but we could absolutely use some simple math to dictate how you want the Choropleths to show up. Another option that we're also evaluating in the future is adding a actual heat map selection where we can use things like log scale to normalize the data to adjust for heat maps. Excelsius doesn't do a great job with using like a logarithmic function, basically. So that's something that you don't have available to you, unfortunately. So that's something we'll certainly plug in here. But for now, the goal is to make sure that we provide as much flexibility as possible to developers. And that's really it. That's all that is required to build a Choropleth or a heat map. Bring in your data, hook up your logic, set up some colors, and publish it out to your end users. So from there, what I'd recommend is going to our Synagogue Knowledge Portal. If you can simply just type in Choropleth. You'll search, and then you'll get one of multiple options. The tutorial, you'll have a blog post that gives you a bunch of resources, and then from here you can actually download this template. So if you go to this tutorial, I'll hide this, you can view the template that I just showed you guys, and then you can actually download the source file right from this page. So definitely go to Senegal Knowledge, look up Choropleths, download the template, and let us know how we can continue improving these templates and videos to help you guys along. So with that, we keep this Tech Tuesday extremely short, hopefully informative. And with that, I will let you guys go and have 15 minutes back of your day. Thanks again for joining. We'll see you guys next Tuesday. Bye-bye.